Right, I now want to do a tranche of 6 integrals, all involving trig functions. Integrals involving trig functions. So here goes. Number 1. Integral between pi upon 2 and 0, 3dx over 13 plus 12 cosine x. And here I'm going to use a standard substitution, which you will do well to learn because it is used over and over again. And that is to let t equal tan over half x. From this, you'll easily be able to deduce that dx equals 2 dt over 1 plus t squared, and that cos x equals 1 minus t squared divided by 1 plus t squared, and we can now substitute that into the integral here. Remember that the limits will have to change, and the new limits will be 1 and 0. And on the top you'll have 3 times 2 dt, and in the denominator 13 plus 12 1 minus t squared over 1 plus t squared, and all of that is multiplied by, on the bottom, by 1 plus t squared. Sorry about the bit of mess over there. I hope you can see that. I'll write it out again. 1, 0, 3 times 2 dt over 13t plus 12 1 minus t squared over 1 plus t squared, all multiplied by 1 plus t squared. And that simplifies out to, quite easily, when you multiply it out, to the integral 6 dt over t squared plus 25. And here we use the tan inverse substitution, rather standard form. Okay, the standard form there being integral dx over b squared plus a squared x squared is 1 over ab tan to the minus 1 ax over b. Well, substituting in, the a will be 5 and the b will be 1. I've got that the wrong way around, but it doesn't matter because it comes down to 6 over 5, 6 over 5 tan inverse x over 5 between the limits 1 and 0, and that finally comes down to 6 over 5 tan inverse 1/5. That disposes of the first question there. Second one is the integral between pi upon 2 and 0 sine to the 4th x cos squared x dx. Well, first of all, let's write that as sine squared x, and in the bracket sine x cos x all squared dx, which equals pi upon 2 and 0. Replace the sine squared x by 1 minus cos 2x over 2. And the sine x cos x is 1/2 of sine 2x. And so that becomes sine 2x over 2 all squared dx. Moving on from there, that now is 1 upon 8 pi upon 2, 0, 1 minus cos 2x times 1 minus cos 4x over 2 dx, which is 1 upon 16. Multiplying it all out, what we get? 1 minus cos 4x minus cos 2x plus cos 2x times cos 4x dx, which equals 1 upon 16 pi upon 2, 0, 1 minus cos 4x minus cos 2x plus cos 2x plus cos 6x over 2 dx. Now, all the terms which have a cosine in it, when you integrate them, will become sines, and sines with even multiples of x. So when you substitute in 0 and pi upon 2, they'll simply disappear. So we're left with 1 upon 16 times the integral pi upon 2, 0 of 1 dx, which will simply come down quite easily, you will find, without any trouble, to pi over 32. That deals with the second integral. Now move on to number 3. Which is 4 dx over sine x plus tan 1/2 of x. And here we'll again use the earlier substitution of t equals tan 1/2 x, which will give us, as before, dx is 2 dt over 1 plus t squared, and sine x is 2t over 1 plus t squared. And we'll just substitute those in to the integral. Should put an arrow sign rather than an equals. So what does that become? That becomes 4 times 2 dt over 2t 1 plus t squared, that's the sine bit, plus t times 1 plus t squared. A bit untidy. Anyway, that comes down to, simplifies quite easily to 8 dt over t into 3 plus t squared. And that decomposes into 8 over 3 using the principle of partial fractions. It's quite straightforward, that, as to 1 over t dt minus 4 upon 3 integral 2 dt over 3 plus t squared. dt. And the first one is just 8 over 3 log n of t, and the second is minus 4 upon 3 log n 3 plus t squared. Okay, and substituting back to give us back our x's, that would be 8 upon 3 log n tan over half x minus 4 upon 3 log n 3 plus tan squared. Tan squared of half x, and that completes it. And now move on to the fourth one. That is the integral between the limits 1 and 0 of x squared tan inverse x dx. You find this much easier if you reverse the order and put in tan inverse x as our first function and x squared as the second. Right? So, use integration by parts. That becomes the first. That's tan inverse x times the integral of the second, which is x cubed upon 3, between the limits 1 and 0, minus 1/3, and the differential of the first, which is 1 over 1 plus x squared, times the integral of the second, which is x cubed upon 3, so that becomes x cubed over 1 plus x squared dx. Working out the first one, where we already know the limits, that simply comes down to pi upon 12, because if tan inverse of 1 is pi upon 4, x is just 1, so that'll be pi upon 12. The bottom, inserting the bottom limit, becomes 0, so that's just pi upon 12, and then minus 1, minus 1/3, and decomposed the second integral as x minus x over 1 plus x squared dx, which equals pi upon 12 minus 1 upon 6 x squared between the limits 1 and 0, and plus 1 upon 6 log n 1 plus x squared, and between the limits 1 and 0, and that finally comes down to pi upon 12 minus 1 upon 6 plus 1 upon 6n upon 6 log n of 2. There's no need to simplify that any further, so we can now move on to the fifth integral, and that is cos x plus sin x over 2 cos squared x dx. Well, we'll split that up as, first of all, a slight hitch in the technology there. So let's continue with this. That becomes 1/2 dx over cos x plus 1/2 sin x over cos squared x dx. I'll call that 1a, and this fellow here b. Well, the first one is a standard integral which we've done before, so that is 1/2 log n of sec x plus tan x. That's a. And for b, well, b can be written as minus 1/2 cosec x to the power, all to the power minus 2 times d cos x, because sin x is the negative of cos x when you differentiate the cos x. Right, so that then is quite simply minus 1/2 cos x to the power minus 1 over minus 1, which is 1/2 sec secant x. So a plus b will give us 1/2 of sec x plus log n sec x plus tan x. And that completes number 5. And now go on to the final one, number 6. And that is to integrate sin x times sin 3x times sin 5x. And of course you're wondering, how on earth am I going to apply the product rule to that? Well, we aren't. So we're going to do it by a different method. So first of all, I'll leave out the integral signs for just now and just look at the function sin x times sin 3x times sin 5x, and write that as sin 3x, and then the other pair combine using the factor formulas to cos 4x minus cos 6x all divided by 2. Okay, so that then becomes 1/2 sin 3x cos 4x minus sin 3x cos 6x. Cos 6x. Which equals, using the factor formulas again, 1 over 4 sin 7x minus sine x minus sine 9x minus sine 3x, which equals 1/4, and putting in order, minus sine x plus sine 3x plus sine 7x minus sine 9x. Just let me quickly check that I've got that right. Minus sine x plus sine 3x plus sine 7x minus sine 9x. Now, the integration of this is quite easy now. So integrating, we get 1/4, and that would be cos x minus cos 3x over 3 minus cos 7x over 7 plus cos 9x over 9, and that completes it.